Good morning and welcome back to Business Math class. Glad to see everyone here. It's really remarkable that as the weather gets nicer, you guys keep showing up. That's super. Yeah, sometimes spring gives us spring fever. I'm real proud of every one of you. We were laughing before class, and I was saying that, you know, I've had this cold, and I know I took too much decongestant before I came to class last time. I want to go and begin by reworking one problem in 6.5 on the handout. Okay, let's do that and get it right, because then a couple people had some homework problems. We'll clear up 6.5 before we go on. If you turn back to your notes on 6.5 rate, we did great on problem 1A. We should have done fine on problem 1B. I'd like to rework problem 1C. This time we'll get the right answer. Is that okay? And I think maybe if you had some homework problems, that was the issue. We've got a 90-day, let me make sure my paper is where I think it is here, 90-day ordinary. It's a discount interest note, ordinary discount note at 11%, $1,000. And do we need to know anything else? No. The question really is, what is the effective rate or the APR? Okay, 90-day ordinary discount interest note, 11%, $1,000. Step one is the calculation of the interest. So we're going to go I equal P times R times T. We should get exactly the same number that we got when we were together last time. I've got 90. Since this is ordinary, we're going to use 360. How much did you get back there? $27.50. Good. We also know that this is discount. So when it's discount interest, do we add or subtract the interest? We subtract the interest. So proceeds, I ended up with, say it real loud. Right. And this is exactly what we had when we were together on Wednesday. Step 2, calculate the rate. This is where I was in a fog. We take the interest, which is $27.50. Rate is I over principal times time. And when we're using APR, what we want for principal is the proceeds, the actual amount of money that the true amount of money that you had to work with, because we're getting a true rate, and we want the true amount of time that you had to work with it underneath there. The true amount of money that you had is you had $972.50 to work with. The amount of time that you had that money was 90 days. What's the true amount of days in a year? 365. And I worked that with 360 again. So my mistake was I put a 360 under there. When we stick that in our calculator, no, you don't. Yeah, when I ran, I got 11.468 something. Are you with me? Mm-hmm. And I said I had 360 there. When we do problem D, it was exact interest, so we use 365 in the original. We use 365 because that's the number of days in a year to come up with the answer. On D, the answer's right, 11.31. We just didn't get the right answer on that one. I rounded it to 4.7. In my calculator, I got 0.11468. 2 decimal places gives you 11.47. Is that all right? And I apologize. No more medication before class. Some days are better than others. Okay, so then Josh said, I had a problem on number 13. So why don't we take a minute and do 13? He thinks he's got it set up right. We'll see what we did together. And he said it could have just been a calculator error, but we'll do it. We have a 270-day ordinary discount. It's called simple discount, which when I see the word discount, what do I know? Subtract interest. Yeah. Subtract interest note. You already see what you did? Okay. 16% interest. Do I need to know anything else? It doesn't matter, right? Since we don't know how much money, it doesn't matter. We could use 100 or we could use 1,000. So we're just going to say that it's $100. Okay. So we're going to set this up and go I equal $100 times the 16% times 270 divided by 360 because it was ordinary. Interest is equal to, what'd somebody get there? 12? $12.
I just didn't subtract the interest from the proceeds.
Oh, so in your second calculation, you also used the $100.
Yeah, I just had to
Okay. So then proceeds, okay, good. Right. Proceeds is 88. So this is exactly like that problem we reviewed at the very beginning. To do the rate, we're going to go, it's the interest, principal, time, but in this particular case, the principal isn't really the principal, it's the amount of money, the proceeds that you actually had to work with. He said, no, I used 270 over 365 for the time, but he knew he had some sort of a problem. Okay, so we're going to go $12 over $88 times, this is going to be 270 days. There was actually 365 days in that year. Rate is going to be, help me, Josh.
18.43.
Percent?
Yeah.
Anyone else agree or disagree? Right. He said I was, oops, this is 88.
Yeah. I just did 100 over 100
Right.
times.
So you've got to reevaluate what's going in for P, what's going in for T when you're converting it to rate. Anything else on that homework on 6.5? As long as you're using years, you don't have to worry about the time changing. As long as you're using months, you don't have to worry. It's only when you've got days, ordinary, that you've got to worry about changing the time. But you've always got to look at what the proceeds are so you know how much money you had to work with for P. Any other questions? Okay. Then we're ready to do the very last section of this chapter that we work on. We're going to do 6.6. Next page. I would encourage every one of you to read the beginning of the chapter on 6.6. Steve did a great job of researching some prior types of payment calculations and came up with a story that's true about the U.S. rule. Basically, until this point, we have borrowed money, held on to the money, and at the end, paid back all of the money with our interest, right? If it was a discount interest note, the person that gave us the loan held on to the interest, gave us a smaller amount of money. At the end, we paid back the maturity value, which was the proceeds plus the interest. Or if it was a simple interest note, we've borrowed the money, and whenever it was due, we gave it back and added the interest to it, right? The one thing we have not done during any of this is made any kind of payments on a loan, and that's a pretty common thing to happen, is that you make payments on a loan, right? If you're making continual payments on a loan, like you are on a house or on a car, yeah, that's going to be handled in Chapter 7 and Chapter 8, okay? If every month you're making the same amount of payments, it's a pre-calculated amount. We're going to use our financial calculator to do that. You borrow money, you're going to pay it off at a certain interest rate over 30 years or over 5 years, and you're going to make monthly payments. Those calculations we're going to do in our financial calculator later on in the chapter. What this is assuming is you borrowed some money, you've got a certain date to pay it back. Are you with me? And what we're going to do is come up with some money in the middle that we're going to apply to the loan. Are you with me? Now, what happens here, it's called the U.S. rule, how we decide what we pay towards principal and what we pay towards interest, is exactly what happens on all of those monthly payments. I mean, the same procedure happens. We're just not going to go through the process of calculating every one of those like we are on these. Okay? It's fairly common for a loan or part of a loan to be paid off before it's due. The U.S. rule is what is used to decide how that payment is applied. When you make a payment towards a loan, always, house, car, or just some loan like we're talking about here, the rule is that you must, from that payment, first pay the interest that has accumulated since you took out the loan or since the last time you made a payment, and then whatever's left after the interest has been paid is applied towards the principal. Okay? Again, in the beginning of that chapter is a story about where this U.S. rule came from. The Supreme Court actually made a decision because someone was paying off a loan and all the money was going to interest and none of it was going to the principal, so the balance of the loan never got any lower. Yeah. So actually, it's not a story. It's a true story, I guess. The widow of this man went to the Supreme Court and said, you know, the calculations were done incorrectly, and the government got involved and said, this is the way it'll be done. Okay? So what we're going to do is talk about a man named Dave. He signed a 180-day note for $5,000, 11% ordinary simple interest on March 7th. Are you seeing the story? Okay. Let me get my papers out here and we'll get going. Dave signs a 180-day note. It's for $5,000, 11% ordinary, which I didn't put in there, simple interest on March 7th. On May 1st, he comes up with some money from someplace and decides to pay $2,000 against that loan. How much is due at maturity? We have lots of questions that we need to answer. First of all, if he signs a note on March 7th for 180 days to begin with, when's it due? September 3rd, she says. Does anyone agree or disagree? How'd you get that?
I added the 180 onto the 66 March, the date.
March 7th is day 66. You added 180 to that.
And I got 246, and that's September 3rd.
Good. So originally it was due on September 3rd, okay? We're going to always come up with these titles that are at the top of each column, and it's going to help us come up with what we're doing. We've got the date that something happened, the principal, the payment, how much went to interest, how much went to principal, and the balance. I'm going to begin by saying, I'm going to scoot this out just a little bit further, that on 3/7, which is March 7th, and day 66, I agree, we came along and we borrowed $5,000. Is that all right? Everything else was blank. That's the beginning of our story. What day is May 1st? What on the table of days? How much? 121. Okay, on May 1st, which is day 121, the principal is $5,000. The payment he made was $2,000. All of that did not go to the principal. He doesn't now owe $3,000. Are you with me? U.S. rule says of that $2,000, he must pay the interest that he owes first. So if he borrowed money on March 7th and it is now May 1st, what we need to calculate is how much interest he owes. I'm going to zoom way in far here. And I'm saying he's got interest due at that point on $5,000 at 11% for 55 days. Where did I come up with 55 days? May 1st is 55 days after March 7th, right. So at that point, he owes interest of $84.03. It's an ordinary 11% loan. He's held that loan for 55 days. What's the question, Kari? It was ordinary. It's not typed in, but I wrote it in, and you need to write it in, ordinary, okay? So at this point, he has accumulated $84.03 worth of interest. He made a payment of $2,000. $84.03 has to go to pay the interest first. Is that all right? So how much went to principal? How much went to principal is the $2,000 that he paid minus the amount that went to interest, $84.03. To principal is $1,915.97. What's his new balance? $3,084.03. Yes, the balance was $5,000. The amount that went to principal was $1,915.95. And his new balance is $3,084.03. Okay? How much does he owe at maturity? This one's a complicated one. Let me wide back out again and let's think about it. Well, first of all, how many more days of interest does he owe? He owes how many more? He owes 125 more days worth of interest. Okay, let me see. I'm having trouble going the right direction. Does everyone see where Marilyn's coming up with 125 days? The loan was actually for a total of 180 days. 55 days in, he makes a payment. So he's got 125 more days of interest to pay. At that point, the interest calculation is based on the balance of 3084.03, right? Okay. 11% interest, 125 days. So on the maturity date, he owes interest of $117.79. Yes? No? Maybe. Fran, what? Why not? Talk to me.
She's just taking the
You see, the balance went down. That's how come you've got to do this chart, or you've kind of got to do it like a ledger sheet. Did you go back to 5,000? Right, on the last 125 days, and that's the reason we're doing the chart, so that you can kind of do it like a ledger and see what you should have. And let me go wide again. Fran, what you should do is back over here. This is the new balance. Are you seeing where I am? Okay. If this was on a blackboard behind me, it would be easier to see. It's hard for me to do it so you can see the numbers and get the scope of the whole thing. But under balance, what we need to do on September 3rd is put 3084.03. Is that all right? Okay. Now, what we really want is the new balance to be 0. I'm trying to scoot this in. Okay. I want the balance to be 0 after this payment. Yes? I need to pay all of the interest, and I need to pay the remaining principal. So how much is this last payment going to be? That's what I come up with.
How'd you get that?
The final payment is made up of all of the interest in the final period plus the remaining balance. So I'm actually taking this to get 0. The final payment has to be, I'm adding these two and backing into this number, $3,201.82. Got it? Yeah. Okay, a couple more questions. How much interest would Dave have paid if he did not make any partial payments? No partial payments. What would his interest have been? Where'd you come up with that, Patrick?
I just did the regular.
That's exactly right. To come up with the interest without any other payments, you would have said $5,000, 11%, 180 days, divided by 360. Without payments, he would have paid $275 in interest. His total would have been at maturity $5,275. Okay, are you with me? How much did Dave save by making partial payments? What total payments did he make right now?
You said that minus 32 and
Good. Tell me what you said one more time, Josh.
well, he saved 552.75 minus.
Right. You're right.
Saved
He
$1,790.
would have paid $5,275. His total payments instead were $5,201.82 because I can accumulate my total payments here. He saved a total of $73.18. Yes, no, maybe. The reason I'm asking some of these questions down here is the computer module has us deal with how much you save by making partial payments, okay? So you need to be able to figure out how much your payments would be to begin with. I mean, what your final, amount that you would have paid would be without partial payments, and then you need to total the payments that Dave made here, subtract that, and come up with what you saved. I'm going to scoot it over here. 275 would be the interest. So, do you understand that one now? Okay. Is everyone with us? Okay. You can see why we're going to let computers do these when we've got 360 payments, like in a 30-year mortgage on a house. Same thing works. I mean, it's exactly the way it works. Has anyone seen a schedule, like for their house payments or their car payments? An amortization schedule, right. We're going to do those in the next chapter. When payments are regularly done, like every month or every 6 months or every year, then you'll end up getting, because you know ahead of time what the payments are going to be. The U.S. rule is what is used over and over and over every month. When you make a house payment or you make a car payment, the portion that applies to interest goes to interest first. Whatever's left over goes to principal. Same thing is true with your credit cards. If you have a MasterCard or a Visa, when you make a payment, if there is any interest due, the amount that goes to interest gets paid first. Whatever's left over goes to principal. So you're not decreasing the principal until you've paid more than the interest that's due. Okay? All right. So when they're regular, monthly, regular, semi-annual or something, we'll be able to generate some amortization schedules. These are when you come into some money and you make a payment that you didn't know you were going to make. Okay? Then someone would have to hand calculate it using the U.S. rule. U.S. rule is used for those others also. Here we go. Next problem. Let me go zoom out a little bit here. And the question is, Susan signs a $10,000 note, 180 days, 12%. I've got ordinary simple interest. I must have been on cough syrup when I typed some of these notes also. I didn't put all the info in. On January the 16th, she, on February 20th, pays $2,500, and on March 20th makes another payment of $3,000. How much does she owe at maturity? We're going to do the same chart. We need to do a few things. We need to first figure out what day on our table of days. And that table of days is pretty handy, isn't it? It is in the back of the book if you ever lose the one that Xerox. I mean, there is one in the book. I just like to have that one for doing homework so we don't have to tear it out. But we need to know what day she borrows money. And then we need to know on what day each of those payments is made. would start my chart by pointing out that on January 16th, she took out the loan. Are you with me? On February 20th, she made a payment, which is day 51. Day 16 is the day she took out the loan originally. March 20th, she made a payment, which is day 79. And July 15th is when the note is actually due. Yeah? The other thing I would do in my chart, and I wish I had little strips of paper to hide my good stuff, is I'd get those payments in there. I would put down that she made a payment of $2,500 on February 20th. She made a payment of $3,000 on March 20th. You know that information from the story, right? The other thing that I know is that the principal on February 20th is $10,000. Are you with the stuff we know already? How can I figure out from this payment of $2,500 what the U.S. rule tells us about how much goes to interest and how much goes to principal? What's our calculation? Calculation that goes right here in the missing box. How many days have passed? Karen, how many days have passed? 35 days have passed. So I equal...
I thought it was 51.
No, it started on day 16. Okay, January 16th is day, are you with me? 16. February 20th is day 51. Because I'm putting the days here, not how many days have passed. It's because it's Friday. Okay, so Karen, what's your setup? Right, what'd you use for principal?
10,000.
Good. Rate was 12, and it's 0.12. Good.
Times 35
Mm-hmm.
over 360.
Good. What'd you get?
116.67.
That's what I got. 116.60.
65 either?
No, it was ordinary.
Does it, oh, both of you. Okay.
Yeah,
All right.
I just scribbled that up there. We're using ordinary. And it is simple interest, right? So if $116.67 went to interest, how much went to principal? Take the payment, subtract the interest, and everything above interest went to principal. So I'm coming across here, and I've got that. The amount that went to principal is $2,383.33. It's $2,500 minus the interest. Then I take the principal, subtract it from the balance, and say the new balance is $7,616.67. Is everyone there? You need to pick that number up. Yeah, this number, and move it way back over to principal. It's the principal coming into the March 20th payment. There or not there?
71. Yeah, 16. Yeah.
Okay. So this column now shows the $7,616 that is accruing interest. Susan's going to make another payment on March 20th, which is day 79. How many days have passed, Josh? Not 79.
63.
Since the last payment.
Oh,
See, we paid all of our interest in full.
28.
Yes. And do you see that the one above it? That's how come I went ahead and put these days here. We had paid all of our interest. We owed no interest on February 20th. We've been accruing interest since February the 20th. So the total number of days from here to here is 28. So the interest calculation in the next payment is only based on the 28 days that we've had interest accruing. Good. What are we going to use for principal? $7,616. Are you with me? And then I've got the 28 here over 360. This is the first time that I've had trouble doing this, that it would be better on a board. I've loved the overhead until now. It's just kind of hard because I keep jumping around. So the amount that went to interest was $71.09. You with me? I take $71.09, subtract it from $3,000, which was the payment, and the amount that goes to interest is $2,928.91. Okay? Holly, are you okay? Back in the back? Everyone looks serious. Okay. I then take the $7,616 balance, subtract how much went to principal, and the remaining balance is $4,687.76. Is everyone seeing what I'm doing? This, subtract that, give you that. This number picks up and comes to the balance at maturity. Yeah, I take the 4,687, scrunch it across. I'm going to fold this up, and that becomes, on July 15th, the amount of balance that I have. Okay? Is everyone there? Now I need to figure out, at maturity, how much interest do I owe? Josh, how many days have passed?
180 days. Oh my God. No, I'm sorry.
It's Friday all day long for Josh.
What was it? 196 minus. What was the other day?
79.
Yeah, 103 days.
Cool. Yeah, we're going to subtract these two. The interest that we're going to calculate is only in this period. Yes. So what did you tell me it is? 117, right? I'm going to use this amount for principal. I'm going to use 12% for rate, and I'm going to use 117 divided by 360 for time, okay? And I'm going to scoot over here, and I'm going to say there's $182.82 worth of interest due on that last 117 days. A couple of other things I'm going to show you. If you add this 25, or 35, this 28, and that 117, you should have paid interest for a total of 180 days, just in pieces, right? All of those time periods together should add to, you said first I paid interest for 35 days, then I paid interest for 28 days, now I'm paying interest for 117 days. I paid interest for a total of 180 days. Since my balance went down, I was multiplying those times by different balances. On my very final day, I owe $182.82 in interest. I obviously have to pay the principal that I owe of $4,687.76 because I want my final balance to be down to zero. I'm going to add those two together to give me my final payment. I need to back into this number by adding the two. So what's my final payment? Yeah. I'm trying to catty corner. Oh, hold on. I'm trying to scoot it up here. $4,870.58. I add all the balance that's due plus all the interest that's due at the end. That's 487058. What was the total amount of all the payments that I made?
4870.58.
Plus 3,000 plus 2,500. Total payments I made. How much money did Susan pay on this loan? Do you understand what we're doing? We're adding all the payments together. Good. How much would she have paid had she not made any partial payments? 10,600. Without partial payments, you would have, I'm getting crazy here. Without partial payments, you would have used, something's in the way here, just a minute. Without partial payments, I would have been 10,000 times 12 times 180 over 360. Without partial payments, she would have owed $600 worth of interest. She would have paid back $10,600. Instead, she paid back $10,370.58. So she saved a total of $229.42 by making partial payments. Okay?
Work. I mean, I thought you'd save more money if you paid it all at once.
Talk to me again, I'm asking.
Isn't that what partial payments are? Is just paying it in instead of paying the whole thing back at once? Is that what you mean by partial?
Yes,
So I thought you would save money.
you did. She saved
I
200.
thought you would save money if you paid it all back at once.
No, because she would have accrued. Okay, if you pay it back sooner, you would.
Yeah.
But okay, and that's a great question. Let's talk about it for just a minute.
Because I thought it.
She only owed interest on $10,000 for 35 days. She saved money because for this 28 days, she only paid interest on $7,600. And on this last 117 days, she only paid interest on $4,600. So this balance kept going down. The interest rate stayed the same, but she didn't owe 12% for 180 days on $10,000 because as the balance went down, she was paying smaller amounts of interest. And so she was saving money by paying, so interest wasn't accruing on this and this during those last days of the loan. Did that make sense why?
Yeah.
No, if you waited and paid it all off at the end, you would owe more money.
Right. But if you paid it all off,
Early, you would save money. Yeah. Yes,
which is what she's doing.
she's right. And a lot of people, and we don't want to get off on different subjects, but a lot of people will maybe come up with an income tax refund or something like that and decide to put money towards the student loan or money towards a car so that it's paid off earlier. And that would, significantly reduce the amount of time that you'd need to pay or the amount of money that you would need to pay. You'd be saving the interest. Does that answer your question? And you see that it would be saving money. Yeah. Paying it all off in the end would cost you more. Like on your credit card, if you pay less each month, less goes to principal. It would cost you more overall, where if you pay more early, less would go, more would go to principal and you'd have less interest during the next month. Okay, Josh asked the question earlier, do we need to memorize this ledger top? Yes, that is what the U.S. rule says. And basically, if you'll think through it, it says whenever you make a partial payment, whatever interest you have accrued so far applies to interest. So any payment, you must calculate the interest first, and the rest goes to principal. You reduce the principal and get a new principal, and you start accruing interest again. But you'll need to make that kind of a ledger to come up with those, for your homework and for the, for the test. You will have a table of days attached to the test and attached to the final to use. You want to take a minute and look at the homework? Okay, let's see what's happening. It's set up very similarly to what we've done, like on problem 1 and 3. It's showing the payments. And you'll just need to make the calculations there.
And it says exact, so it's 365.
Yes, on this particular one, it says exact. Get that up on here. Just give me a minute. In case somebody doesn't have their book. It says complete each table, applying payments according to the U.S. rule using exact interest. So what we're going to do is we borrowed $18,000. We've made a pay on 6/15. We're going to look up that date. We made a payment of $4,000 on July 23rd, so we're going to figure out how many days have passed, calculate the interest. This $18,000 will come over here and be the principal. When we calculate the interest, that's how much goes to interest. The rest will go to the balance. We'll subtract $18,000 from the amount that went to the principal or to the balance to come up with a new number, bring it back over. And $365. In problems number 5, it says to use ordinary interest, so you'll do what we did, use ordinary interest. Let's see what else is going on, 11 and 13. $11 looks exactly like example 2 that we did in the homework. 13 and 15 do the same thing. There'll be one of these on the review, and there'll be one of these, on the test. You do kind of need to set it up like a ledger and do it. Now that you've looked at the homework, are there questions? Okay, then I'll let you get started on it. We'll end the tapes, and we'll see you Monday.